Let's say this problem sort list. Actually, there I have given one linked list, and we have to sort it in ascending order. How will we sort? We can sort it using merge sort. In merge sort, what we do? We divide each list in two parts until we get the single element. So like that also we will approach here. So at first we will have to find out the mid element for dividing it in two parts, because we have to divide this list in two parts, so there should be some mid element now. So how will we find out the mid element? In array there is simply total number of elements divided by 2, but in linked list we can't go like that. So what we will have to do, here it can be the case like I take 2 pointer, one is slow and another is fast. This is head element. So this fast will move 2 times of this slow. That means until fast move 10 times, then slow will move 5 times. Until f move 11 times, then slow will also move 5 times, 5 or 6 times, okay, whatever. So in this case our pointer of slow can be mid element, so we will move here like that, okay. Last this one can be none. So if slow move one pointer, fast will move 2 places here, and again fast can move 2 places, so slow will move here and fast will go to none. Now we can't move, so we can take next of this slow pointer as a mid element. So here mid can be next of a slow, and then we will divide in two lists, one for, and this one at first I will make none. So I will just break down this list in two parts. So in one part it will be -1, 5, 3. Next is none. This will be our left part, and other part is 4, 0. Its next part is none. Okay, we have divided in two parts, left and right. We will divide until we get the single element, okay, and then we will merge each single element by comparison. So we will again find out the mid element here, and see for this mid element will be S for slow and F for fast. It will move one pointer S, and F will go here. So here left part will be -1 and 5, next will be none, and right part will be 3, none. This is right part. Actually see, we have divided here from this two parts. This is left, this is right. From here we have divided two parts, left, and this is right. Here also two parts will be, so left part will be 4 only, single element, none, and right part will be 0, none. This is left, this is right. Again we can divide this one in two parts. This will be -1, none. This is 5, none. Left, right. Now see, each single element we have find out. Now we have to merge all the single element. So how will we merge? Actually I will take one dummy pointer or current pointer. So this is current pointer, okay. Initially we will show this by dummy pointer also, so dummy will be fixed. See, we have to compare left and right part, each part recursively, because there are how many left and right part? 1 here, this is 2, this is 3, and here 4. See, first level, second level, 3, 4, this left and right. So 4 levels are there, and we have to merge at each level. So at first, see, on first level, this is left and right. We will compare which one is lesser. So whatever is lesser, current dot next will be that pointer. So this left value is lesser, so current next will be -1, and this left will point to this none now, because left will be updated to none. Now whatever is left and right, it will be appended here. So -1 and 5, and this right will be none. So see, -1 and 5 we have merged. So this one is left part, and right part is now 3. So again we will compare left and right part. So now left part is this complete part, and right part is here 3. So we have to merge both of these two parts. So again we will compare both the list. This is left list and this is right list, okay. So again we will compare and we will merge. Actually this is done recursively, okay. So again we will define one current and dummy list. In that case current will be again updated So from left and right part we will compare, and whatever is lesser that will come at first. So -1, then 3, then 5. So this will be now complete left part. See, -1, 5, 3. -1, 5, 3. This left part is now sorted. Okay. So right part is left. Now we have to sort with this right part. So left part is here sorted. So just compare this left part with right part. It will again sort. So here again we will check for new list. So what is right value? 4. So it will be merged in the same way. -1, 3, 4, 5. -1, 3, 4. Okay, sorry. This part, in this part there are two lists now, 4 and 0. At first these two parts will be sorted. So this will be 0 from current. 1 second. This is current. So 0 and 4. So this is the sorted part of this right part here. So here this sorted part will be compared with this left part. This is right part now. So actually here after -1 now it should have come 0. I forgot to check. Actually there are two elements now, -4, 4 and 0. So after -1 0 will come, then 3 will come, 4, and last 5. So see, this is sorted now. -1, 0, 3, 4, 5. What was our initial list? -1, 5, 3, 4, 0. So we have merged. After breaking down in left and right part, we have merged the list, and this is the sorted list. So what is our initial pointer? This was initialized with current and dummy, but current has been updated. I think it has come till here. And this is still dummy. Dummy we have not changed. So its next pointer, this one. So this is the head pointer. So we will just return dummy.head. That is the initial pointer of the sorted list. Let's see this program, sort list. As I already have explained. So now see its code. Head pointer of this list has been given, and we have to find out the sorted list head pointer. Okay. So at first we will check the condition if there is only one element or there are no element. There is no element. See, like this, there is nothing inside here, and if there is only one element, then also it is sorted, and if there is nothing element inside here, then also it is sorted. So if not head or not head dot next, if there is nothing, not head, or if there is only head, then not head dot next, then in that case we will return head. This is the head pointer of the initial item. Okay. Now we have to find out the mid value of this list. So already explained, I will take two pointer, one for fast movement and one for slow movement. So slow and fast. This will be slow will be head, and fast will be head dot next. So we will go inside this while loop until we have fast and fast dot next, because we have to move two times faster. So I have taken fast and fast dot next because I have to check fast dot next. So it will move 2 pointers next. So I will have to check fast dot next also. Slow will be slow dot next. It will move single item, but fast will move two items. Fast will be fast dot next dot next. That means fast is moving 2 times faster than slow. So in this case, like one is moving 2 times faster, then of course whoever is slow, it will just move half distance. So from here, mid will be slow dot next. 2 times faster means what? Whoever is slow, that is at the half distance. And slow dot next, now here I will point to none. So mid element we have found out. Now we will do recursive calling of this. There will be two functions because mid, that means this list will be divided in two parts, one before mid and another from mid. So there will be left and right part. So left will be self dot sort list. This will start with head, and right will be self dot sort list. This will start with mid. Okay. Actually, this will be divided in two parts of the list, left part and right part. Now we will define one dummy node or one node for updating the current value. So this will be dummy. I will point this one current also equal to list node. So this is just a new node. Okay, new list node. I have taken two value here because one value I have to keep constant and one value we have to move. So I will compare in both the list, left and right, both the lists. So while L and R, if there are some items in both the lists, then I will check whichever is lesser, which value is lesser. If L dot value is lesser than R dot value, then in this case what happens? Actually, see here, minus 103, and this will be divided in last minus 1 and 5. So see, minus 1 and 5, lastly there will be two items, minus 1 and 5. So it will check minus 1 is less than 5. So minus 1 is left part and 5 is right part. So after checking left value, its current value will be updated. Current is dummy node. So current dot next will be this left value, left item. Actually, current next pointer will be this left node, and now left we will update to next node. So left will be left dot next. That means in that case it will point to none. And current node also we will have to update, because one item has gone inside this new list node. So current will be now this left node, or we will just see current dot next already taken. Okay, so current we will have to update with current will be current dot next. Whatever item has come inside of this list, now current will move to next item. Okay, else in this case r value is greater than r value is less than or equal to left value. So current dot next, same case like that, r and right item we will increase to next value, r dot next, and current will be updated with next item, current dot next, because one item has been added inside of this linked list, so its current value should be also updated with next pointer. So like this it will check until there are some element inside left and right list. So if any item has got finished, if any list has got finished, that means now there are no items, so it will come outside of the while loop. And in this case we will update current dot next equal to, if there is some item left, because this is AND condition here, while L and R. So if any item is still left in any of the list, then we will update here current dot next will be, if there is some element in left, then L, or if there is some element in right, then right part. Okay, and now finally we will return dummy dot next, because dummy has not changed its position. Current has been updated every time, but dummy is still pointing to initial node, initial pointer of the node. So our head will be, this is the pointer of head of the new merged list. So head will be dummy dot next. See, I just repeat this again. If there is no element, not head, or if there is only single element, then just we will return head. What I have done, I have find out the mid value by taking slow and fast pointer. Then I have divided in two part, left list and right list part by mid value, and I have taken one current node and dummy node. Actually, this will be divided until I get only one item in each list, in each left and right list, and then it will be merged inside of this new list. So I have taken a pointer for new list node. It will be merged each time from two items. It will go till next of merged list, and then like that all the list will be merged, and finally one complete merged list will come that will be sorted. So it will recursively call this left and right lists, and it will merge here by just appending inside a new list. So finally we will return the dummy dot next. This will be the pointer of head of the new merged list. Just run this program. Okay, there L is small, it should be capital, and LIS. Accepted, submit. Okay, submitted. Thank you.